Hi, I'm Fritha and I'm here to talk to you today about adapting to change. So today I'll give you a bit of an introduction about me and why I'm here to talk to you, some stories, talk to you about adapting for change in general. I'll talk to you about the Christchurch earthquake background, a bit about SCIRT, Stronger Christchurch Infrastructure Rebuild Team, a bit about change within the earthquake rebuild, innovation. I'll give you a bit of a summary and then we'll have questions at the end. Let's set the scene. So I'm Fritha McCrimmon-Robinson. I work as a project engineer for Stantec, but I have a lot of different hats. Consider this as an invitation to invite me on LinkedIn and have a chat to me. I know it's going to be harder to network in this kind of virtual conference than it is in a normal conference. So pretend we've met at coffee at a conference, send me a message and feel free to have a chat. So why have I been invited to talk to you about adapting for change? There's two main reasons, and that is my experience with the Christchurch earthquakes, but also the UK floods. So the first Christchurch earthquake in September, I was a civil engineering student. I was asleep in my house living with lots of different engineers. And the second earthquake happened at 12:51 p.m. in February, and I was on the 5th floor of the Commerce Building in a sewerage lecture. And after these earthquakes, we then had lectures in tents and in churches, and there was a massive clean-up. So I was part of the student army digging liquefaction out of people's houses. And I was also working as a structural civil engineer, doing structural assessments on people's houses. I was then soon after that employed by SCIRT, which is Stronger Christchurch Infrastructure Rebuild Team, as a project engineer, and that's mainly what I'm going to be talking to you about today. And that picture on the top right there is of us doing liquefaction out of people's houses. So that's the pictures of the student army. So my other experience is with the UK floods. So I moved to the UK Hi, I'm Fritha and I'm here to talk to you today about adapting to change. So today I'll give you a bit of an introduction about me and why I'm here to talk to you, some stories, talk to you about adapting for change in general. I'll talk to you about the Christchurch earthquake background, a bit about SCIRT, Stronger Christchurch Infrastructure Rebuild Team, a bit about change within the earthquake rebuild, innovation. I'll give you a bit of a summary and then we'll have questions at the end. Let's set the scene. So I'm Fritha McCrimmon-Robinson. I work as a project engineer for Stantec, but I have a lot of different hats. Consider this as an invitation to invite me on LinkedIn and have a chat to me. I know it's going to be harder to network in this kind of virtual conference than it is in a normal conference. So pretend we've met at coffee at a conference, send me a message and feel free to have a chat. So why have I been invited to talk to you about adapting for change? There's two main reasons, and that is my experience with the Christchurch earthquakes, but also the UK floods. So the first Christchurch earthquake in September, I was a civil engineering student. I was asleep in my house living with lots of different engineers. And the second earthquake happened at 12:51 p.m. in February, and I was on the 5th floor of the Commerce Building in a sewerage lecture. And after these earthquakes, we then had lectures in tents and in churches, and there was a massive cleanup. So I was part of the student army digging liquefaction out of people's houses, and I was also working as a structural civil engineer, doing structural assessments on people's houses. I was then soon after that employed by SCIRT, which is Stronger Christchurch Infrastructure Rebuild Team, as a project engineer, and that's mainly what I'm going to be talking to you about today. And that picture on the top right there is of us doing liquefaction out of people's houses. So that's the pictures of the student army. So my other experience is with the UK floods. So I moved to the UK 5 years ago, and I worked initially at the Environment Agency as a flood and coastal risk management officer. And 1 week into the job, the worst floods in a decade hit the north of England. So this picture here on the bottom is of Corbridge, the floods in Corbridge, which was one of my study areas. So adapting for change. So just to let you know, this picture that I've got here is of liquefaction in Christchurch. So it may look like flooding, but those areas of flood, that's actually liquefaction. So that's silt and sands all mixed up with water. Then it all dries out and it turns into this hard concrete-like substance that is then all through people's houses. So change can happen in lots of different forms. It's not just the earthquake and floods that I'm going to be talking about, but you might be able to compare this to some of the things that are happening in your projects. For example, the pandemic. No one would have seen or expected this pandemic, and probably you haven't planned for it within construction. So similar to the earthquake. But some of the other things that we've got is aftershocks. So aftershocks were happening constantly after the earthquake, and so that was expected to some extent and therefore was planned for in construction. However, I don't think people ever foresaw that the aftershocks would cause quite as much damage as they did. Other things that can happen that can change projects are key personnel changes, or the site could be closed for various reasons, archaeological find, and many other changes. So how do we adapt to all of these changes? So I think some of the soft skills that we need to be able to adapt to change in construction is that we need to be agile and adaptable, we need to be flexible, resilient, and we need to be quick thinking. But how do we do it? So we need to have strategies in place to deal with the change. So we need to have strategies in place before a project starts to know how we're going to deal with change. And we need to deal with them in the most efficient way possible. So we need to be adaptable and agile with both the planning and the execution. And we need to plan projects to have resilience. So this is having the capacity within our projects to bounce back so that it can enable us to cope with these surprises and adjust to the change accordingly. So one thing to think about is how can you plan for the unexpected and the unforeseeable within your projects? Can you have a general plan of how you might adapt to change? Not necessarily this is the change that I want to adapt for, therefore I need to make a plan, but how can I adapt for change in a very general way? So now I'm talking about the earthquake rebuild. So a bit of background about the earthquakes. So there were the two main earthquakes, the Darfield quake, which was a magnitude 7.1 earthquake and 1.2 G, and the Christchurch quake, which was 6.3 magnitude but 2.2 G. So the earthquakes were an eastward migrating sequence. So they started in the west and moved further to the east. They got closer to the city, and therefore that's why the aftershocks, we saw more damage than we did the initial quake. And this was the most energetic aftershock sequence ever observed. And the shaking of 2.2 G was the strongest ever recorded on land. So the earthquake subsided most of the city because of the ground type. So you can see in the map on the top right hand corner the subsidence and the uplift. So because of the ground type being a marshy sand, the majority of the ground settled between 0.5 metre and 1 metre. And that map we've got on the bottom there is just showing all the aftershocks and earthquakes. So each one of those dots represents a different aftershock or earthquake. So these are the infrastructure totals of damage, just to give you an idea of the scale of this thing. So we had 90 kilometres of water main. Lots of those were already PE, so quite flexible, so it did cope with the earthquake all right, which is why we've only got 90 kilometres. Wastewater, we've got 500 kilometres of sewers. That's because it was mostly clay and concrete, so they broke very easily during the earthquake. And with those, a lot of pump stations for both wastewater and water. Roading, 1.3 million square metres of roading, and 324 bridges and retaining wall that were damaged. There's also other aspects to the clean-up and damage. For example, the emergency repairs that were required, so a lot of overpumping and discharging to rivers in the first instance, and also people using portaloos and chemical toilets. But also we had a lot of temporary repairs, for example, to the roading, to be able to drive down the road in any way, so we just needed a quick grade and rolled so that cars could get down it, that would then come back later to repair properly. So to be able to deal with all this damage, SCIRT was formed. SCIRT, so Stronger Christchurch Infrastructure Rebuild Team, was made up of 5 delivery teams, of which Fulton Hogan was one that I was working for. So it was a virtual organisation, so nobody worked directly for SCIRT, but everyone was seconded in from their various companies. And we had a design team of 250 people all housed in one building, and it was really encouraged to have interaction, and that's how it was laid out. So to give you an idea of timeframes, this was set up after the February earthquake. The initial SCIRT design started in May, and the first engineers started in-house in August, and everything was brought into that house over time. So as I said, there were 5 delivery teams, Fulton Hogan being one of them that I worked for. And between those 5 delivery teams, there were over 700 projects completed over the 5 years. And it was set up very differently from standard projects in that performance determined how much work you were allocated. And there was a big focus on safety, value, our team, environment, and customer satisfaction. So this really influenced behaviours and delivered outstanding outcomes. This is just some of the things that were measured on to give you an idea. So there's a big push for innovation, safety, health and well-being, community, waste minimisation. So as I said, it was all set up quite differently to normal. So each contractor was given a package of work with a TOC, that's a target outturn cost, that was set by SCIRT. So as a contractor, we then had to look for innovations and opportunities to be able to save money. So we needed to plan and program the works and get bids from subcontractors to be able to turn a profit. And there was a requirement that 40% of the work had to be subcontracted to keep the smaller businesses going. And so we had to continue looking for innovations and time and cost savings during construction. And there was a shared pain gain between the contractors. So this meant that actually you wanted everyone to succeed. So the people who would have been your competitors, you now want to do very well. So very different to normal. But obviously with this vast amount of work that needed to be done, lots of things couldn't happen the way that we would normally do it. So for example, traffic management. So it was in a post-disaster rebuild. We had to have different methods of planning the traffic. So we had a forwards work viewer to prioritise and plan for the works, and red zones were set up. So instead of having 30 sites within a red zone, with cones tapered out, workman signs, 30-kilometre speed signs, cone taper back out, work end site. You just have signs every 5 metres or so within the red zone. So instead of that, we had a red zone where the whole zone was a construction site. So you had working men signs and speed signs on the outside of the red zone, and everything within that was a work site for traffic management purposes, even if there were hundreds of different contractors within that area. So obviously there's a lot of change that's already happened because of the earthquake, but we also had constant change happening within the projects because of aftershocks and flooding. So for example, when an aftershock happens, lots of different things can change. The levels of the structures that you already have levels for might change. Your benchmarks that you've been using for survey might change. But also personal circumstances for your team might change, because we're all having to clear up our houses every time an earthquake happens, or we might be looking after family members. And another thing to consider is that the work that we've already completed might have moved. So the pipes that we've just laid might have all settled or have dips in them or become disjointed. And also temporary works might have been damaged, for example, scaffolding collapsed. But also because of the subsidence over the city that I talked about, it meant that there was areas where the high tide level was actually higher than the ground level, so there was tidal flooding in people's houses and on people's streets every high tide, twice a day. But also other flooding, so we've got damage to the stormwater systems and therefore less capacity to deal with the stormwater. So every time it rains, the streets are flooding, people's houses are flooding, your work sites are flooding. So how do we adapt to this change during construction, during these projects? So we needed to have strategies in place to deal with the change, and we needed to plan for these aftershocks. We needed to deal with them in the most efficient way possible. We've got hundreds of sites and hundreds of people working for us, and we can't be taking our time to make decisions on things. Things need to happen quite quickly. And we need the team to be adaptable and agile. It's all very well a few of you being adaptable, but everyone's work is constantly changing, so we all need to be adaptable and agile. And we need to plan these projects to have resilience. The projects need to have the capacity to bounce back and enable us to cope with the surprises. And we need to be able to adjust accordingly to them. We also need to know, and this is really important, we need to know where we don't have the flexibility for this. Where do we not have the time or space to change, and how are we going to deal with that? For example, you've got a really tight space in terms of services, an earthquake happens and things are wiggling around. How are we going to deal with it? We don't have space. What are we going to do? How are we going to change things? The other thing to consider is changes from changes. So one change can have a knock-on effect to so many other aspects of the work, but also onto many other projects. So an aftershock can disrupt projects and result in changes in lots of different things, including required material, design, permits, labour and man hours, time, budget, customer expectation, liaison with other shareholders, just to name a few. But also this can have a knock-on to other projects. The crews might then have something that they need to go straight onto, but also someone else might be coming into the street to do another project straight after who can't. Change has some good outcomes though, in that it drives innovation. So there were lots of innovations that came out of SCIRT. So it was recognised very early on that standard designs weren't going to be suitable, so we needed to have more resilient designs and structures put in place. So there were a lot of designs that came out of this, as innovations that are now being used elsewhere as well. And we needed things to be able to withstand liquefactions, and we needed alternative sewer systems that were going to be more flexible to be able to cope with further aftershocks. And also there were hundreds of construction innovations. So we needed methods to reduce impact, make it safer, more cost effective and quicker. And we needed to reduce the impact to the rivers and the trees and the wildlife. We needed to recycle and reduce waste and reduce noise. So there were 600 innovations that were implemented as a part of the strategy. Just to give you a wee snapshot of it, for example, environmental sustainability. These are some of the innovations that came out of it. For example, single tree protection. So the idea that if every project saves one tree, then we're talking 700 projects over the span of the rebuild, so that's 700 trees that were saved. Hydro excavation to make it safer and more cost and time effective. It's all well and good having all of these innovations if we're not going to do anything with them though. So all of these innovations were put on an innovation register, and that then linked into our leaderboard, which I'll talk about in a second. So there was a leaderboard for projects. So this encouraged innovation, and this leaderboard had lots of different components to it, and we were marked on various things. For example, safety and environment, and how we're doing with program and cost. So this encouraged innovation, and we were encouraged to have 2 innovations per project per month, one of which was submitted to the Skirt board each month, and we got points for replicating other people's innovations. We were also judged on our environmental audits each month, so this meant that we had really clean and tidy sites, and it encouraged great environmental scores. So these KPIs and the leaderboard then represents the allocation of work. So the higher you got with these scores on the leaderboard, the more work you got. So if there was 100 million to spend one month, and it would be 20 million if it was all even over every project. But if one team's doing a lot better, they get more allocation of work. So there's a really strong push to do really well on these leaderboards, and therefore innovation is really driven. So that's about all I'm going to talk about. So this is a bit of a summary about what we've talked about. So the Christchurch earthquake posed many changes to project, and we need to adopt a more adaptable and agile approach to planning and execution. We need to plan projects to have resilience and the capacity to bounce back and enable us to cope with surprises and adjust accordingly. Change can be both unexpected or expected. It can be planned for or unplanned, caused by many different things. We talked about floods and earthquake, but also pandemic or key personnel changes. One change can have a push on to many other aspects of work, and it can also impact many other projects. An aftershock can disrupt projects and result in changes in required materials, permits, labour, man hours, time, budget, customer expectation, for example. Change drives innovation. Change is an opportunity to try something new, and we need to be resilient. So I think that's all I've got to talk to you about today, but thank you very much for listening, and please do get in touch, and hopefully we'll meet in the future. Thank you.